Section number 3 covers questions number 9 and 10. 9 states, direct variation is defined as y equals kx, where k does not equal 0 and the coefficient k is the constant of variation. Consider your answer to item 2. Now remember, item 2 said y equals 10x. So it says, what is the constant of variation for your function? Well, it's 10, because that's my k in this problem. It says, why do you think the coefficient is called the constant of variation? Well, the height constantly varies by 10 with each addition of another box. Explain why the value of k cannot be equal to 0. Well, let's take a look. If k equals 0, then y equals 0 times x, which is just 0, right? Which means that the value of y will always be 0 and will not vary. All right, let's take a look at D. Write an equation for finding the constant of variation by solving the equation y equals kx for k. So if I have y equals kx and my ultimate goal is to get k by itself, we would need to divide both sides of the equation by x. So y over x equals k. Let's move to question number 10. Question number 10 says, interpret the meaning at the point 0, 0 in your table and graph. Well, remember that 0 as an x represented the number of boxes. So a stack of 0 boxes has a height of 0 centimeters. True or false? Explain your answer. The graphs of all direct variations are lines that pass through the point 0, 0. Okay, this would be true. In an equation, of the form, oops, should have said form there, y equals kx, when x is 0, then y equals 0. Identify the slope and y-intercept in the graph of the stacking boxes. Well, my slope in that stacking boxes problem is 10. What is my y-intercept? My y-intercept is 0, 0. Describe the relationship between the constant of variation and the slope. Well, The constant of variation was 10, and the slope is 10. So the constant of variation and the slope are equal. On to your next set of problems.